Hello, everybody. Welcome to the Construction Record Podcast. I'm digital media editor Warren Frey, and with me today I have.
I'm Eric Law. I'm co-founder and CEO of Urban Machine.
And that's a good place to start. Urban Machine doesn't really give away what you do, which is you have I'm going to get this wrong, you're going to get this right. It's basically a robot that takes material out of wood to make it recyclable. I'm assuming that's right, but please explain what I've gotten wrong there.
Yeah, no, you got it right. And the material we're removing is the nails, screws, and staples. So essentially, we're automating nail pulling. That's what we're doing with our robotics.
And I went through your blog with the history of the company, and it said a company that started with garbage, which is a great headline, by the way. As a reporter, I can tell you what a good headline, and that is a good one. So why don't you go into what that means? What was the inspiration generally, and how does garbage fit into this?
Yeah. So how does one trip on recycling wood and technology, right? So the last engagement I had, I was working for a large general contractor here in the U.S. based out of San Francisco. And I built their innovation program where we focused on bringing robotics into construction to augment our craft shortage. And we really focused on field applications for those robotics. And while I was there, I also got involved with their sustainability initiative, where we were looking at waste streams coming off of construction projects. And what we learned is concrete and steel both have recycle paths, energy intensive, but the material is not going to landfills. Whereas the wood waste, which was the other predominant material, was heading to landfills and a little bit to incineration. And it's like, why is this, beautiful, strong, high strength material going to waste when we take down a building? And as I dug deeper into the issue, it's because of the metal. You can't mill it, you can't plane it when it's got metal fasteners in it, so you can't really reuse it. It doesn't fit back in the lumber ecosystem. And so I reached out to a roboticist that I knew who I'd worked with on some other research projects. I said, hey, can we automate this? And he's like, absolutely. And he started building a prototype. And that was a little over a year and a half ago now. And then off we went in 2021 with that prototype to raise some money and start on the mission of reclaiming lumber from construction and demolition. The problem is massive. In the US alone, it's 37 million tons of dimensional lumber heads to our landfills every year. Put that in perspective, that's about half of what we log from our softwood forests.
Okay, and I saw on the site itself and stuff on LinkedIn that you use AI. Now I know you know better than I do since you're in the Bay Area. The AI can be used as a buzzword just to get funding. I'm pretty sure that's not what you're doing. So how does AI figure into all this?
Yeah, so what we're doing is we're using computer vision cameras to take pictures of the material. And with those pictures, we want to identify the fasteners, the orientation of the fasteners, the type of fastener, and then we use our pick plans to go and remove it the best way possible. And so what we've been doing is running lots of wood through our cameras to take lots of pictures to train our software on here's all the different orientations for fasteners, here's all the different types of fasteners. And it's really, we have to build our own training data set. Right? Nobody else is out there taking pictures of lumber full of nails, screws, and staples.
Probably not, no.
And then we have to teach it, what's a knot, what's a split, how to look at quality of lumber. And so for our software team, it's been a lot of training. And that's what really AI is all about, is taking a large data set to train the software to be able to recognize, hey, this is a nail that's bent over. Here's how you should pick it. This is a screw. Here's the machine that should remove the screw. And so that's where the AI part comes into it, is essentially training the computers to be smart.
And so, well, when you say robot, it could mean something that takes up a factory floor or something that is, in the corner somewhere. What is the size and what are the roles of this thing? Like, could a company theoretically just buy it and put it in the back of their workshop?
Yeah, so the process line, so for a full process, that is brushes, nail, staple, screw removal, metal detector at the end. It's about an 80-foot length process line. Our first unit is coming out here in the next month and a half. And that unit is actually going to be on trailers. So we can take it to job sites, we can take it to waste facilities for pilot projects with these companies to show it working.
Okay.
And get ourselves a lot more data coming in from the field. What's all the actual dimensions of lumber that we're processing, our volumes, our throughputs, and really test out the equipment. And the reason why we're doing that is early on, we thought, let's set this stuff up in a factory and dump trucks will bring us material. So one day we had two big 40-yard dump trucks with the tall sides come dump in our shop. And the first truckload, the material went racing across the floor and broke one of our prototypes. And
oh, dear.
Yeah, we quickly learned that dump trucks emptying lumber does a couple things. One, it creates a big mess that now you got to sort
Mhm.
out. Two, a lot of the material was getting damaged coming out of the back of the dump trucks, and a lot of the fasteners were getting smashed into the wood, making the problem harder. So we said, that's not such a good idea. What happens if we take this technology and we put it on trailers and we go to the job site? And so that was a huge win in terms of making that change because we eliminated a truck trip.
Mhm.
Once we clean all the metal out of the wood, then we can ship it like normal lumber. We can bundle it up on flatbed trucks and send it off to our customers. And then it saves us from having to set up these warehouses and inventory material and double and triple handle material. So it's actually a really nice way to deliver our solution is mobile. Uh, and so it's going to be on two 40-foot flatbed trailers for this first iteration.
Mhm.
And we're looking forward to, we'll do videos and stuff of that here in June and sharing that with everyone as well to show these things out at job sites, cleaning up lumber as the buildings get demolished.
Now, I was going to say that if this sounds like something that couldn't have been done before AI. Now, construction is well known to not do stuff even when it is possible because they have ways
Yeah.
of doing things. How much of this was due to, okay, now we can do this because AI is powerful enough? And B, did you run into any resistance? Because construction is, they're a lot better than they used to be, but they're pretty technology avoidant or have been anyway.
Yes, absolutely. As someone who spent 20 years in construction and
Mm.
technology, trying to put the two together, it is a big challenge within the industry. And so, what we're doing is the nice part is we're operating the technology. So, we're our own customer.
Mhm.
And then we're actually going into the material collection business where we're going to take the wood from the contractors off their job sites.
Oh, okay.
So instead of them having to grind it up or truck it to a landfill and pay tipping fees, we're like, hey, we'll take this material for free from you guys from your job sites, and then it actually saves you some money. And contractors are very interested in that. When you give them a proposal that reduces their costs, they want to listen. And then we'll take the risk of selling it back into the wood industry. So we're actually going to be in the wood market for a couple of years because the waste industry is not connected to the lumber industry, right? Those two
Oh,
don't
okay.
usually supply each other. So we're going to do that. And that gives us an opportunity to run the machines and improve the technology and get the experience we need in the field to make our machines better.
And just in terms of what can this thing do beyond wood, or does this have applications beyond wood? Could you take this technology and adapt it to some other thing that is sort of in the same vein but a different material?
Yeah, so we're looking at, wood comes in different shapes and sizes. This first version is really on your dimensional lumbers and your engineered lumbers like glulam. We're looking at down the road of going after your sheet goods. Think plywood and OSB and all those sheet goods where our end effectors would be the same, but it's a different handling format, right? So we got to have
Mhm.
a much wider machine to handle a 4x8 sheet of plywood coming through it. And then you have different forces that come into play as well. It's not like a 2x cross section where you can put hundreds of pounds of force on it. Plywood, you can't do that. So it's really just changing our handling mechanism in terms of how we move that material through the machine, but we get to use our same end effector technology on it.
And I would assume one of the drivers behind this is climate, because if you've got a bunch of wood lying in a landfill, yeah, okay, it's not as bad as say having steel in a landfill, but
Yeah.
it's still reusing is better.
Absolutely. And what we're finding is you've got landfills, predominantly here in North America, but then when you go over to like Europe, they're doing a lot of incineration with their material, right? They don't have the landfill space
Hmm.
like we do in the US. So your choice is a trickle release of carbon, a couple percent a year in a landfill, or an instantaneous release when you incinerate it. Neither one is good, right? And the nice part is the EPA has done some studies for us comparing the energy to reclaim lumber to the energy to process virgin lumber. And most people are looking at wood as a more sustainable building material when you look at the carbon footprints of steel and
Hmm.
concrete because they're fairly energy intensive. And it's about 90% less energy to process reclaimed wood than it is for virgin because our feedstock is already dry. It's
Right.
been sitting in a building for 40 to 100 years, dry, straight, held in place really well.
Hmm.
So it's really high quality material that we're processing, much higher quality than what you get out of the forest today.
And what kind of interest have you seen? Like, well, actually, how far back? When did you start? And then what's the interest been sort of up to now?
Yeah, so everybody we talk to loves it. Everybody's like, yeah, this is obvious. Why hasn't anybody done this before? It's a massive problem in terms of volume material available. It's something that, everybody loves. The architecture and design community is like, wow, we can use reclaimed lumber and we don't have to pay 10x for it.
Hmm.
They're like, this is phenomenal. Because up until today, it's mostly, small folks doing barn wood and historic building deconstruction, and it's hand denailing it. So it's pretty expensive material.
Mm-hmm.
And so our goal is to make a large volume of this available so it can go into your standard lumber ecosystem. You'll see it go into engineered lumber products, go into wall facades and stuff. And then the other cool part too is you can share the story. We can track what building most of this material comes out of because we're at the demo site and we know the building that's coming down. And then we can use a little printer technology to put a QR code on it that says, hey, hit this QR code and learn about where this piece of lumber came from. And that's valuable. People like a story. They like to understand history. And the cool part about wood is we can do that. We can track and share that story.
And from a climate perspective, that's important too, because you'd be able to track the materials and where they're going and how long it takes to get there and all the rest of it.
Exactly. Yep. You got it.
And so if people are, and I would assume they would be, if people are interested in what Urban Machine's doing and what the future holds for you guys, where would they go to find that out?
Yeah, hit up our website, urbanmachine.build, or follow us on LinkedIn. LinkedIn is where we post most of our updates. Typically, Jorah and our marketing team posts them every week in terms of how we're doing. We post videos and photos of what the team's up to, events we're at, how the technology is progressing. And then we also do podcasts occasionally as well with our technical team, where they sit down and share about lessons learned and kind of give people insights into how we're doing on the technical side of this problem.
Okay, great. Thanks for joining us today, Eric.
Awesome. Thank you very much for having me, Warren.